Here I have an assembly with a block and a rivet. The block is fixed in space, and the rivet is free to move and rotate. I'll use these two components to demonstrate a number of different standard mates available in Solidworks. Before beginning to add mates, I would like to detail which selections can be made in order to add mates between these components. I can select two faces or surfaces, a line or linear edge, planes, an axis or temporary axis, a point, vertex, or coordinate system, or an arc or circular edge. The selection entities determine which types of mates are available for the parts, so choosing the correct entities is an important part of properly constraining the components. To begin mating these two parts, I will need to activate the Mates tool. Mates can be found in the Assembly tab of the Command Manager, under the Insert drop-down menu, and by pressing the S key to access the shortcut menu. When I click to activate the tool, the Property Manager updates, and a list of mate options becomes available. There are two main tabs, the Mates tab and the Analysis tab. I will focus on the settings found in the Mates tab, as the options in the Analysis tab are suited for a more advanced lesson. Within the Mates tab, the Mate Selections box displays which faces, planes, edges, or points are selected to mate together, along with a button to toggle Multi-Mate mode. This mode is used in more advanced mate scenarios, so I'll leave this topic for another lesson. Below this box, there is a section for Standard Mates, which are the mate options that I will be focusing on in this lesson. Below this, there are more options for Advanced Mates and Mechanical Mates, which are also used in more advanced mate scenarios and are covered in another lesson. There is another box called Mates that displays the current mate that is being created, and there is an options box with checkboxes that help display and control mates. I'll leave these options at their defaults, scroll up to the Standard Mate section, and begin with the Coincident Mate. The Coincident Mate constrains two components to have their faces, edges, or other selected entities remain coinciding with one another. To clarify, this does not necessarily mean that the components will remain in contact, but the selections will always coincide. To demonstrate this, I will click the Coincident Mate type in the Property Manager. I will choose the top face of the block and the bottom face of the rivet as the selections. Notice that the rivet moves in the graphics area, and the context toolbar appears with other available mate types, as well as options to flip the mate alignment, undo the selections, or complete the mate. If the parts orient incorrectly when the entities are selected, use either the Mate Alignment button shown in the Property Manager or the Flip Mate Alignment button in the Context toolbar. I'll click the green check to complete the Coincident Mate. The Property Manager stays open to add additional mates. Now these two faces will remain coincident, and if I close the Property Manager and move the rivet around in the graphics area, these two faces will always remain coincident in every planar direction, even if the components do not remain in contact. This coincident mate has also been added to the Mates folder, which can be seen by expanding the folder in the Feature Manager tree. Rather than deleting this mate, I'll go ahead and click on the mate in the Feature Manager tree, and click Edit Feature. I'll clear the selections from the Mate Selections box by right-clicking and selecting Clear Selections, and I'll move on to the Parallel Mate type. A parallel mate forces two selected entities to always remain parallel, such as faces, axes, or edges. I'll click the Parallel option in the Property Manager, and I'll choose the front face of the block and the top face of the rivet as the mate selections. The rivet rotates so that the faces become parallel. I'll click the green check, exit the Property Manager, click the X-axis of the reference triad, And as I move the rivet in the graphics area, these component faces remain parallel. If I right-click and hold to rotate the rivet, notice that the part can only rotate about the rivet's central axis. The parallel mate restricts it from fully rotating. I'll go ahead and edit the mate again. Clear the selections and demonstrate the perpendicular mate type. The perpendicular mate performs similarly to the parallel mate type, with the exception that the selected entities are constrained to remain perpendicular rather than parallel. I'll choose perpendicular from the Property Manager, and if I select the same two faces I chose for the parallel mate, the rivet rotates and the faces are constrained to a perpendicular relationship. If I try to rotate the part, the rivet will only rotate in such a way that these faces remain perpendicular. In the next video, I'll demonstrate the remaining standard mate types. The next standard mate type is the tangent mate. This mate constrains two selected entities to remain tangent to one another, such as two faces or a face and an edge. Before I create the tangent mate, I'll add a coincident mate between the bottom of the rivet and the front face of the block. This will help illustrate how the tangent mate specifically performs. This time, I'll create the tangent mate without selecting the mate type in the Property Manager. I can go ahead and select the cylindrical rivet shaft and the top face of the block. And if I choose Tangent from the Property Manager, the rivet moves and the shaft remains tangent to the face. I'll make sure the parts are aligned properly and click the green check. I'll exit the Mate tool, and when I move the rivet remains constrained to the top face of the block. I'll make sure to keep the coincident mate, and I'll go ahead and edit the tangent mate to move on to the concentric mate option. A concentric mate constrains two circular selections to share a common central axis. To help illustrate this, I'll turn on temporary axes for the components by clicking the Hide Show Items icon in the Heads Up toolbar and enabling View Temporary Axes. I'll clear the mate selections, choose the concentric option in the Property Manager, and I'll choose the cylindrical face on the shaft of the rivet and the circular face of the block. And the rivet moves in such a way that the central axes of both faces coincide. Also notice there is an additional checkbox option available in the Context toolbar called Lock Rotation, which is also available in the Property Manager. When selected, the two components will be restricted from rotating relative to one another while remaining concentric. I'll leave this option cleared. Click the green check and exit the Mate tool. Now if I right-click and hold to rotate the rivet, it stays in one spot and simply rotates around its central axis. I'll turn off temporary axes and edit the mate to move on to the distance mate. The distance mate constrains two selected entities to remain a certain distance from one another, such as two faces or two edges. I'll go ahead and clear the mate selections. Select the distance options from the Property Manager. Select the rivet shaft and select the top face of the block. The rivet moves, and a distance value is required to set the distance between the central axis of the rivet and the top face of the block. I'll enter a value of 15 millimeters, and the position of the rivet updates. I'll click the green check, exit the Mate tool, and when I try to move the rivet, it remains at the specified distance above the top face of the block. The last standard mate type that forces alignment between parts is the angle mate type. This mate constrains two selected entities to maintain a specified angle between them, such as two faces or two edges. To demonstrate the angle mate type, I'll need to suppress the coincident mate, which I can do by clicking on it in the feature tree and selecting Suppress. Now the coincident mate is no longer constraining the rivet and block. Now I'll edit the distance mate, clear the selections, and select the Angle Mate option in the Property Manager. I'll choose the top face of the block. and the bottom face of the rivet as the mate selections, and the rivet rotates according to the specified angle. If I change this value to 60 degrees in the context toolbar, the rivet rotates again to maintain the constraint. If the two components are intersecting when the angle mate is applied, I can use the mate alignment options in the Property Manager to properly align the parts, as well as the Flip Dimension checkbox. If I click the green check to complete the mate, and I right-click and drag the part to rotate it, the two faces remain at the specified angle. There is one remaining standard mate type available, the lock mate. This mate restricts any movement between two parts, making them fixed in space relative to one another. To demonstrate this mate, I will delete the angle mate by scrolling down in the Property Manager, right-clicking on it in the Mates box, and selecting Delete. I'll scroll back up. I'll choose the Lock Mate option in the Standard Mates box, and I'll select both components in the Graphics area. Now these two parts cannot move or rotate, which I can verify by trying to click and drag the rivet in the Graphics area. Solidworks also displays the message, "The selected component is fully defined. It cannot be moved." This completes adding the various types of standard mates, and I will click the green check to exit the mate tool.